afternoon.
Thank you very much for coming for today's session. I hope you are energetic for maths class. Today we are going to look at a new strand which is calculus. Alright, so let's begin. Alright, to recap, we have already covered calculus in year 12 book. The simply what is like how we gonna differentiate it. It's y equals to k x to the power n, right? So that n will come in front, right? The k will multiply with k and x, then minus 1 from the n. So that's the basic rule for calculus. Simply something like this: n multiplied by x to the power n minus 1, right? So now I'm going to give you an example where y equals to e to the power 1, right? When we differentiate any exponential, it will be like same. There will be no change. So that means y equals to e to the power x will be remain when we differentiate it. It will remain as e to the power x, right? So thank you. Before we begin with year 13 calculus, I just like to advise you some classroom rules. If you have any question, you always have a right to ask. You can always raise your hand. I will going to answer your question. Please do not shout, and always respect or appreciate each other's opinion, right? So let's start. Learning outcome. On the successful completion of this strand, you should be able to outline the different techniques of differentiation. Secondly, we have to know what is a constant rule, what is a product rule, the quotient rule, and the chain rule. Alright? Alright, I have a short video on calculus before we're gonna go over the notes, right? The actual notes. So let's start.
The only thing that is constant is change. Everything around us is always changing. We see things moving, the weather keeps changing, prices of things are always changing, the temperature of the earth keeps rising, our population keeps increasing, and many more such changes. Wouldn't it be amazing if we could predict how things are going to change? Well, in many cases, calculus is a branch of mathematics that can do this. For example, calculus is used for analyzing the motion of objects, and then to build the models to predict the trajectory of things like rockets. It can be used to analyze the money coming in and out of a business, and then to build models to maximize its profit. Calculus can be referred to as the mathematics of change. So to develop the skill of predicting change in the upcoming set of videos, we are going to understand the basic concepts of calculus. Limits, differentiation, and integration are the important ideas around which calculus is built. First, we understand these ideas. In calculus, we mostly study things which change according to a pattern. These patterns of change are mathematically represented by the concept of functions. So the concept of functions is the main object of study in calculus, and therefore we will understand it well. And finally, we will see how to use the ideas of limits, differentiation, and integration to analyze functions. So to see a positive change in your knowledge of mathematics, watch the upcoming videos to understand the basics of calculus.
Alright, from the interesting short video we have learned that calculus is a mathematics and change, and how the strand 3 and strand 5 is related to calculus. Strand by functions and limits is a major role they're gonna play in strand by, which is calculus, right? So differentiation, we are going to talk about differentiation. So like simply y dash is there, that means we're gonna differentiate it, right? ln x. ln x simply means when you differentiate ln x, it's 1 upon x, right? Sin x, when you differentiate sin x, we get cos x, right? When we differentiate cos, it will be negative sin x. And tangent is secant squared x, right? When you differentiate tan, we're gonna get secant squared x, right? Alright, let us do one example for better understanding, right? Alright, this is our function fx is equals to x squared minus 1. In order to differentiate, the right. So x, these two will come in front. That means 2 multiplied by x, the power will be separated by 1. That means 2 minus 1. So this is a constant, this is a variable. So there is no x, that means it will be 0. Alright? There is no x, it will be 0. So therefore our final answer will be 2x. We don't write 1, it's simply in linear algebra, anything to the power 1 is the same thing as 2x. Right? Alright, from this trend we are going to focus on these 7 things: constant rule, power rule, sum rule, product rule, quotient rule, exponential function, and chain rule. These all are techniques of differentiation. Now I am going to play a short video for your better understanding. Alright class, let's pay attention to this video, it's very informative.
On derivatives in calculus. So let's say I want to find the derivative of this function at x equals 3. So to solve this problem, I need to find the derivative f prime of x, which is just the derivative of this function with respect to x. So what I can do is use the power rule shortcut, where I take the power of each variable, I multiply it by the front of that variable, and then I subtract 1 from the power. So doing this power rule, I'm going to end up with 3x squared for this first term, and I'm going to end up with just 5 for this second term. I need to evaluate this at x equals 3. So f prime of 3 is going to be equal to 3 times 3 squared minus 5. 3 squared times 3 is 27, and then I subtract off this 5, I'm going to end up with 22. This value basically tells us that if we look at our function at x equals 3, the rate of change at this specific point is equal to 22. That's the idea of derivatives in less than a minute. Here's a quick video on derivatives in calculus. So let's say I want to find the derivative of this function at x equals 3. So to solve this problem, I need to find the derivative f prime of x, which is just the derivative of this function.
Alright, constant rule is our first rule. Our function is c, and c is a element of real numbers, right? Our f dash is equals to 0, right? That's a prime number. So our question is f dash of 5. When we differentiate 5, we're gonna get 0. There's something simple. Any constant will automatically give us 0, right? Alright, for power rule is our second technique. For any power function, say fx is equals to x to the power n, where n is a real number, the derivative of f with respect to x is f dash of x is equals to n will come in front, x remain at is and minus 1 from the power, that is n. Simply reduce this power by 1, and multiply the power. So this one will multiply here. So n multiplied by x, n to the power minus 1. Alright, let's solve the power rule example on the board. Alright, this is our function g of x is equals to 3x squared plus 3 root x, right? You are wondering this 3 root x is how I gonna differentiate it. It's a very simple question, right? So let me just briefly going to write this again. G of x is equals to 3x squared, right? Plus x to the power 1/3. Now it's simple.
Yes.
Then now we find the g prime of x. G prime of x is equal to, the power rule comes in, these two will multiply in front, 2 multiplied by 3, then x remains at easy, then minus 1 from the power, right? Plus x 1/3, so this 1/3 will come in front, minus 1 from the power, right? So g dash of x is equals to 6x plus
1/3.
that becomes this 1/3 minus 1, right? So we gonna get 2/3 in the power 1/3. So you can leave your answers here. Alright, our main agenda of this class is the product and the quotient rule, right? That is number 4, product rule. Let us discuss on this. So product rule, g multiplied by f, right? So how we gonna differentiate it? Simply, this is very difficult. We must be wondering how we gonna do this. Simply, you know this one. This is the formula. You can eat it. So f of g dash prime, f dash multiplied by g function plus g dash multiplied by f function. That's the formula. So let's do one example. Alright, now we're gonna solve example 1, question number 8. Y equals to x squared minus 1 multiplied by x plus 2, right? Alright, may I have your attention on the board, please? Y equals to x squared minus 1 multiplied by x plus c. This is the product rule. The function is something f dash g plus g dash f. I told you to create this formula. This is very beneficial. So we have to know this is f, this is g. Alright? First thing we're gonna do this. Then f is equals to x squared minus 1. G is equals to x plus 2. Then we find the f dash, right? How to find the f dash? Simply you differentiate it. When you differentiate f, we're gonna get 2x, right? Minus 1, we have learned that any constant is 0, right? G dash, so x plus 2. So x has a power 1, multiply by 1, that is anything multiplied by any number 1, it will be remains that number. So it means will become x. So constant will always become 0. So this is our f dash and g dash. Let's plug in this formula. So f dash is 2x multiplied by g, x plus 2, and plus g dash is x multiplied by f is x squared minus 1. You can remain your answer as it is. That's your full mark. Right, you can leave your answers here for full mark, or you can simply, if the quotient has simplified, you can always simplify this. So this one will multiply here, 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 right? So 2x multiplied by x is 2x squared plus 4x plus x squared x cubed minus x. Alright? So x cubed plus 2x plus 3x is your final answer. Thank you. Right, your second example is your homework. So I will discuss this in tomorrow's class, right?
Yes, sir.
Right, our second the fifth is a quotient rule. Quotient rule is simply, I give you a very shortcut method. Is simply f divided by g. A function f divided by g. So equals f dash is multiplied by g minus f multiplied by g dash divided by g squared. Right? It must be you must be thinking what I'm saying, but let's do an example. It's for better understanding, right? Right. This is our example. Differentiate function f where negative 3x plus 2 divided by x plus 1, right? This is our second first example for quotient rule. So the function is negative 3x plus 2, that is our f function, right? And x plus 2 is our g function. We have already we have identified a function and g function. Now let's write the rule. F over g is equals to g times f minus f g divided by g squared, right? G squared. So our f is equals to f is negative 3x plus 2 and f dash is equal to f dash is we are gonna differentiate this, right? So that is 3x. Then g is equals to x plus 1. G dash is equals to 1. So let's plug to the equation. Equation gonna drive you, don't drive the equation. Otherwise, if you drive the equation, you're gonna get wrong answers. So f g dash f minus f dash g divided by g squared. So g dash is 1 multiplied by f is negative 3x plus 2, then minus f dash is here negative 3 multiplied by g dash is x plus 1 divided by x squared x plus 1 squared, right? If you leave your answers, I'm gonna give you full mark. However, if the question is simplified, then we have to simplify this equation. So that is negative, anything multiplied by 1 is simply the same element. So negative 3x plus 2 minus this bracket will go here. So this becomes 3x plus 3 divided by x plus 1 x plus 1, right? So that is negative 3x plus 2 minus 3x plus 3. You get for the like term, this one and this one is a like term. This is minus, that becomes negative 3x and and positive. Alright, so we have missed the negative sign here. So when we negative 3x minus, use bracket for if so that your answer is correct, right? Minus 3x, so this one and this one will cancel. Minus become plus, right? So this is plus 3. So it's 5 divided by x plus 1. X plus 1. You can always. This is our last thing, chain rule. Chain rule, simply the rule contains the differentiation of composite function, where y is equals to function f is multiplied by g of x, right? So this is our example. Simply is two parts, where the inner part and the outer part. So I know it's a bit confusing, so you can note it down. The simple step where the power comes in front, right? This bracket remains a digit minus 1 from the power, differentiate the bracket. So there's the rule. Alright, let's discuss this example and after that we collide. Our function is y equals to x cubed plus 1 to the power 7. Alright, so power comes in front, 7 into x cubed plus 1, bracket remains a digit, minus 1 from the power, so 7 minus 1 into differentiate the bracket, so 3x squared. So simply 7 into x cubed plus 1 to the power 6 into 3x squared. Your answer, you can even answer it easily. That's your chain rule. I hope you have learned these 7 steps, and from 7 at least 3, the main one, product, quotient and chain rule, you must be knowing. So let's recap. We have discussed the constant rule first. Constant rule, for example 1 is there, so it becomes 0 in differentiation. Then we have discussed the product rule. There is a function, the equation you have to know, same thing as quotient rule, same thing as chain rule. Now let's move on to the last activity, and that's your homework as well, right? From this 4 activity, which one I should discuss?
First one.
First one, right? Then the third, second, third, and fourth will be your homework, right?
Yes.
So let's discuss the first one. This is very simple. We have to just differentiate it. F of the function f is equals to 3x plus 5. So in order to differentiate it, we know the constant rule. Any constant is equals to 0, right? So thus we are left with 3x. So the f dash of x is equals to 3. That's the answer, right? Alright, thank you very much for your attention and your time, and I hope you're gonna come prepared for next class with completed your homework activity. Thank you.